Hi, my name is Roxy Wilcox and my partner is Ava Robinson, and this is our Spring 2021 quarterly update for knowledge maps. The problem is that there exists a wide gap in knowledge between the many novice web developers and the few CSS experts. Why is this the case? The jump from novice to expert is difficult to achieve with current resources for learning CSS. There are many resources for learning basic CSS syntax and gaining contextual understanding, but there are not good resources for gaining conceptual knowledge of CSS, which is required to have a professional understanding of CSS and employ professional techniques. Like I mentioned, there are many solutions that do not help users reach the level of professional knowledge necessary to become a CSS expert. These solutions are either too trivial and teach you details of syntax in context, or too complex for novices to understand and learn from. Some examples of current solutions are W3 schools. These are tutorials that are taught in a constrained and contextual way, so users cannot apply their techniques to different complex situations. Number 2, Flexbox Froggy and Grid Garden. These teach you how to use one technique, flex or grid respectively, but they don't teach you when to use the techniques or which technique you should use. Chrome Developer Tools. Chrome Developer Tools is useful for exploring professional websites, but it contains a lot of excess information and is difficult to parse through for beginners. The Knowledge Maps tool as of the end of winter quarter attempts to address this gap in conceptual knowledge of professional CSS techniques by allowing you to compare two professional websites and the relevant interactive code snippets side by side. By being able to resize the windows of the two websites side by side and by highlighting code similarities and differences, users can identify visual and code differences. This does help users compare and contrast the two pairs of sites that are built out in the tool, flex versus flex and grid versus grid, and gain an understanding of the effects of different CSS techniques. However, it does not help users create a map of CSS knowledge which is necessary to reach the level of conceptual understanding that professionals have.
Our focus for this quarter was building out a grid knowledge map. Our goal is to understand how we can help users build a map of knowledge of grid CSS techniques to gain better conceptual understanding and become more of an expert in CSS grid. We decided to slice down the project to focus only on CSS grid layout techniques so that we could deeply understand how to help users build out a knowledge map and become experts for one specific example. We chose grid because our current KM tool already has one professional grid example and analysis of this example to use as a model. Grid is also a commonly used technique and has strong effects on the visual layout, so it is easy to identify visual differences in grid layouts, and it's important for a developer to understand how to achieve these different visual outcomes. Although grid is only one way to achieve some layouts, it is complex in itself, as you can generate a vast variety of different visual layouts, and you can use many different techniques within grid. Because of these complexities, we think grid is a good example for building out a knowledge map. In order to help users build out their own knowledge map of CSS grid layouts, we first needed to understand for ourselves what a grid knowledge map really means. To do this, we followed a few steps. First, we became experts in CSS grid ourselves. We used existing tools such as Grid Garden, W3 Schools, Medium articles, and conducted expert interviews. After gaining this knowledge, we found and examined multiple professional websites that use CSS grid. We used Chrome Developer Tools and played around with the sites to identify important visual features and understand how they were implemented. Finally, after identifying patterns in both technique and approach, we were able to build out our own knowledge map of grid. We created groups within the knowledge map, both by technique and approach. Here is our example of a grid knowledge map with categories grouped by feature or visual outcome. You can see that this would allow someone to understand the different techniques that can be used to achieve a particular visual feature. For example, to achieve a responsive number of columns, which was observed in two sites, you can use either span and media queries or repeat autofill to achieve this visual effect. Building our knowledge map was imperative to helping us create design arguments.
In order to create design arguments for building out a knowledge map of visual features of professional sites, we had to first define our user outcomes. What did we want users to achieve with our tool? We decided that users should be able to build and understand a knowledge map of CSS grid examples by 1. Identifying the CSS technique responsible for producing a given visual outcome on a web page, and 2. Identifying patterns in visual feature and CSS approach to categorize and group web pages by approach and by feature. There were several obstacles that had the potential to block us from reaching our desired user outcome. Number 1, it is challenging for users to turn the information they know about CSS Grid into knowledge because they often only understand the information on a contextual level. They may understand why a certain CSS technique is used in one particular instance, but would not be able to apply that knowledge to future situations or understand how it could be used in different websites. Number 2, users may struggle to identify relevant patterns when looking at websites individually because it is overwhelming to explore some websites. There are often many CSS properties used on a particular site, so it can be difficult to know which CSS properties are relevant to the visual outcome seen on the website. Number 3, users might identify a relevant feature but not identify the correct CSS code that's producing that feature. This would cause the user to learn the CSS technique incorrectly and as a result produce an incorrect knowledge map. To both achieve our user goals and overcome the potential obstacles, we came up with a set of design characteristics for our revised Knowledge Maps tool. Number 1, give users an example of a knowledge map so they have an idea of what they're working towards. Number 2, make users compare and contrast sites with similar CSS techniques but different visual outcomes. This helps them build out the categories for a CSS approach knowledge map because they see how the same CSS techniques can be used in different ways. Number 3, make users compare and contrast sites with different CSS techniques but similar visual outcomes. This helps them build out the categories for a visual feature knowledge map because they see how the same visual features can be achieved with different CSS techniques. Number 4, ask users to describe the salient visual features of each site and identify the CSS technique responsible for said features. This helps them reflect on their finding and gives them a summary that they can more easily use to create categories for knowledge maps. And number 5, tell users to use their answers to the above prompts where they recognize the salient features and responsible techniques to guide their categorization of the sites in a knowledge map. We ran 3 different design sprints with 3 different iterations of our prototype. After analyzing the study findings, we came to the conclusion that number 1, users need a clear understanding of what a knowledge map is because it's such an abstract idea. Number 2, users should have autonomy over creating their own knowledge map categories. Giving them category names was helping them too much and not allowing them to recognize patterns for themselves. Number 3, users should find the relevant CSS techniques themselves. Giving them the technique names was also helping them too much and they weren't able to understand the techniques fully by themselves. Number 4, it's important to resize the window to see how the web page changes behavior in order to understand how each CSS technique affects the visual outcome. Number 5, it's important to be able to change the values so users can understand how each CSS technique affects the visual outcome. These were features of this Knowledge Maps tool as of the end of winter quarter, and they were critical in helping users understand how the CSS techniques affect the visual outcomes on each site. Number 6, it's useful to pair the sites by similar technique or by similar visual outcome. Pairing the sites by similar technique allowed users to see how the same technique can be used to achieve different visual outcomes. Pairing the sites by similar visual outcome allowed users to see how different techniques can be used to achieve the same visual outcome. This was integral in helping users group the sites by either similar visual outcome or by similar technique. These groupings helped them define categories for their own knowledge map. Providing pairings in this way was a happy medium between giving them predefined category names, which was helping them too much, and providing them with no guidance for the knowledge map, which was not helping them enough, because building out the knowledge map proved to be the most difficult part of the process.
One of our design sprints helped refine our user outcomes. We realized from our test that we need to continue to slice down even more to get specific user outcomes and be able to measure success. Here, you see an example of a knowledge map a user created during one of our user tests. This user test was left open-ended on purpose so as to see how someone might build their own knowledge map with little structure. The user successfully identified that grid template columns was a common attribute used in the CSS code of all the sites. Via website comparison and resizing the windows in our tool, they also identified that some sites have a static number of columns while others have a change in number of columns and sizes. However, the user did not correctly identify the approaches or understand the differences in approaches between the two sites with a shared similar visual outcome. This made it apparent that a challenge for users is understanding the relationship between all of the information, especially when there is a lack of structure given in the test. This helped us redefine our goal. The goal of a knowledge map by visual feature is to allow users to understand what different techniques can be used to achieve a particular visual outcome. Now I'm going to show you a demo of our updated knowledge map site and prototype. Here is our updated Knowledge Maps interactive tool prototype. As you can see, users can select the pair of sites they want to compare in the tool. Users can then use the window size controller to resize the sites side by side. This allows users to see how the sites respond to window size changes, and specifically allows them to notice differences in the grid layout techniques. Users can also scroll down and view the CSS code for each site. The snippets shown are parts of the CSS that are responsible for the grid layouts and relevant to the professional technique used. In addition to modifications to the KM site comparison interface, as I just showed, our prototype also has reflection and scaffolding questions. After the user uses the tool to explore a pair of sites, we ask them to reflect on what the similar and different visual features are across the two sites. We then ask them to list the most relevant features of each site and the corresponding technique that produced that feature. These questions guide users to reflect on the new information they learned and summarize the information in a structured way to help them be less overwhelmed by looking at so many sites and begin to recognize patterns. This is also meant to help users think more deeply about which techniques are responsible for which feature. Examples of a visual feature a user might list could be a responsive number of columns or a grid element sizing staying the same regardless of window size. Techniques could be attribute value pairs, such as media queries, grid area, or any other important properties or values. Users will respond to the reflection and scaffolding questions for each pair of sites they explore. The choice of pairs of sites in the comparison is therefore important. For testing if users could build a knowledge map group by visual feature, we paired sites that had similar visual features but implemented using different techniques to help them in recognizing the relevant patterns needed to build a knowledge map. Finally, after exploring the sites and responding to reflection questions, users will be given a dashboard where they get to build their own knowledge map. The feature and approach under each site are auto-filled with the responses from previous scaffolding questions. This is a system model that needs to continue to be worked out. The goal is to provide users with an easy-to-view overview of the information they have and encourage them to turn it into knowledge by recognizing patterns and relationships and dragging the sites into a visual knowledge map. Ideally, users would group the sites by a shared visual feature.
The risks in our current prototype are: how does users building a knowledge map help them have better conceptual understanding? What's the benefit in making them build out the knowledge map themselves versus just giving them a correct knowledge map? Number 2, how can we help users explore the relevant visual and code features of websites while still giving them exploratory freedom to recognize patterns on their own? And number 3, how does the code highlighting of the original Knowledge Maps tool help for examples where the significant CSS properties are not shared in any way and therefore not highlighted? How will users be pointed to the relevant code to look at? Potential next steps. The potential next steps for the project are: number 1, testing users' understanding after building a knowledge map. Given a set of professional websites, can users identify which technique was used or which technique they would have used to reach the visual outcomes in each website? Number 2, adding more grid websites. Number 3, making code interactive by plugging it into the original Knowledge Maps tool so that users can toggle with the values and see how that affects the visual outcomes of each site. And number 4, building out the system models. If we don't want to hard code the example pairings, how are these pairings chosen by the user or created? Some points of personal growth this quarter were: number 1, slicing down our project to focus only on CSS Grid. We made the most progress whenever we got more specific with our tasks. Number 2, sprint planning. We made actionable sprint items with concrete deliverables to work towards each week. Number 3, fast design iterations. We produced a new prototype every week to use in user testing. Number 4, accepting sunk cost. We accepted that a few weeks of work needed to be scratched in order to push our project in the right direction. We still have many things to work on, including: number 1, accepting scrappiness as sufficient. We need to learn to be okay with design arguments and prototypes that are scrappy in order to iterate quickly and move forward with the project at a reasonable pace. Number 2, reaching out for help. We need to be less shy when asking others for help, especially if they do not respond right away. We also need to come up with more creative sources for help if our initial source is not proving effective, so that we are not blocked on making progress on the project.
Thank you for listening to our quarterly update.